Today we're starting electromagnetism. Alright, the symbol for charge is Q. So also the convention is that positive is red. So this is Q. And negatively charged things are blue. Here's a negative charged thing. We'll call this Q prime. Q and Q prime is just the convention, the first and the second thing. There's not a change of charge here. There's two different charges, Q and Q prime. Like I said, Q is the symbol for charge. Charges are measured in coulombs. And that's a C as the symbol for coulombs. And a coulomb is, well, actually, to give you an idea, 10 coulombs is about how much there is in a lightning bolt. So a coulomb is about a tenth of a lightning bolt. Anyway. Alright, so we understand that red's typically positive, blue's typically negative. So if we have a positive and a negative charge here, hopefully we understand that they are going to attract, like I mentioned earlier, before I said it wrong, or after I said it wrong. Opposite charges tend to attract. How much do they tend to attract? Well, to figure that out, we can use something called Coulomb's law. Coulomb's law. And Coulomb's law is this. F equals K Q prime over D squared. And well, D is distance, it's just how far apart they are, it's in meters. Q and Q prime are your two different charges. Alright? And K is a constant. K depends on the units that you're using, but since we're using coulombs and meters, our K is going to be equal to this. 9.0 times 10 to the 9th, and it has a weird unit, Newton meters squared per Coulomb squared. And that's just because when we put that in, the per Coulomb square will cancel here, the meter squared cancels that, we're left with newtons, force is in newtons. There we go. Coulomb's law is what you use to find an electrical force. Now, when using Coulomb's law, your force is either going to be a positive number or it's going to be a negative number. The convention is that a positive number means repulsion, meaning that the two objects, or the two charges, are going to push away from each other. A negative number means attraction, and that's key. That's something you can get confused about really easily. So it's really important that you take very good care to pay attention to your signs. Alright, so a quick example. This is going to be, what is this? This is the example on page 418. This is part B that I'm going to do. So it says object A, we'll call this object A. Object A has a positive charge of 6 times 10 to the negative 6th coulombs. And object B has a negative charge of 3 times 10 to the negative 6 coulombs. We want to, and how far apart are they? They are 0.03 0 meters apart. And notice this is a very small charge and a very small distance. Coulomb's law holds no matter what this charge is or the distance is. It's just that to get a meaningful force for a small distance, you'll have a small charge. Well, for a small charge, you need a small distance. For a larger charge, you can have a larger distance. But anyway, counter force here. Well, first of all, since these are different charges, this is a negative charge. Like we said earlier, they should attract, so our answer should be negative. So F equals KQ Q prime over D squared. We'll just plug in our K, which is 9.0 times 10 to the 9th. Our Q is 6.0 times 10 to the negative 6th. Our Q prime is negative 3.0 times 10 to the negative 6th. All of that divided by 0.03 squared. And you just plug in, crunch the numbers, and you end up with a force of about negative 180. About negative 180 newtons of force. And remember, a negative force means attraction, which is what we should get. And why is our answer negative? Because there's a negative here, all the rest are positive. When you square this, it's going to be positive. We'll have a negative divided by positive. Our final answer is negative. So this is pretty easy. I may ask you to find forces, I may ask you to find charges, I may ask you to find distances. It's just algebra. Just because sometimes you guys, your brains turn off when I ask you to do algebra. I guess I'll show you how to rearrange Coulomb's law a little bit. I'll write it over again just to start. So F equals KQ Q prime over D squared. So what if we wanted to solve for one of the Q's? Well, we'd have to get Q by itself, so we'd have F D squared equals KQ Q prime. If we wanted Q, we'd have to divide by KQ prime, so it'd be F D squared divided by KQ prime. If you want a Q prime, you just switch the Q's. You would divide by KQ instead of KQ prime. You're never going to solve for K because that's a constant. You'll occasionally need to solve for D, so if you need to solve for D, well, here's the first case. If you need to solve, oops, I should draw that arrow here. If we need to solve for D, then we'd have to divide by F, so we'd have D squared equals KQ Q prime over F, and then we gotta write the square, so we'd have D equals the square root of KQ Q prime over F. That's if we would want to solve for D. Now, I am not going to provide either of these two equations for you on the test. So if you want to memorize them, I suppose that's fine. But guys, really, this is simple algebra. Everyone should be able to take this formula and solve it for whatever variable you need. This isn't bad.